So we're very pleased to have Nick Kentish join us today for his third webinar with us in our RegenWA series. Firstly, I'd like to acknowledge the traditional custodians of the land and pay our respects to the cultural elders of the past, present and emerging, and acknowledge their spiritual connection to country. Today I sit here in Whadjuk land where it is the season of Mycorrhizal. This season saw the coming of the first rains and allowed free movement across the land to hunt for red meat animals, for food and clothing to help ward off the cold. And I know here in Perth we felt the cold this morning. RegenWA believes in regenerating our regional landscapes and communities. We focus on supporting farmers who are investigating alternative production practices with the aim of minimising or reversing the impact of productivity constraints like climate change and acidity. Nick has a wealth of knowledge about agriculture and livestock management, having travelled Australia and abroad as a stock handler. He now resides in the Adelaide Hills after having a much larger cropping and livestock farm, where he and his family went on a journey to develop an ecosystem grounded in biological diversity. Nick is a trainer, coach and senior consultant with RCS and an all-round good bloke. He joins us for our 6th RegenWA webinar to continue the conversation on what steps to take when you head back out into your paddocks. Now I'll hand over to you, Nick, if you want to start sharing your screen.
Thanks, Shay. Sorry for the delay. Thanks for having me. It's a beautiful day here in Adelaide Hills. Thanks for sending us all that good weather from Western Australia. I hope that you've been getting a share of rain as it comes across. I hear it's a little patchy, but I hope that the patches are working for you and filling in as we go. So it's taken a bit of a while to get to the how-to in what we've been talking about in this series, but I thought that it was pretty important to address first in the previous couple of webinars the fact that the first change we've got to make between our ears, and that bit of real estate in there is so indelibly important to the change. You can't actually do anything physically in the field until that change is up there. So the example that I'll give you is from the photograph that I've just taken there, and if you whiz back through the webinar series, that is that's taken from exactly the same place as my first two slides. One was the straight after seeding, one was the germination, and that one is there at some early tillering of barley. And the people who have asked me to come up there and help them, well, in actual fact, it's mother of the family. She is really intent on wanting to make a change and take the leap. And the men in her family are firmly rooted to their position, that they want to retain their current strategies and habits, that anything regenerative is not for them right now. They actually fear that it will cost too much to do. And so that was really helpful when she said to me, because I thought, what I want to get across to you guys is that this is not about going to cost too much. It actually will cost less in time, because we're actually getting Mother Nature to do a lot of the heavy lifting for us. And we're just going to supply some helpful starter cultures and some helpful systems and helpful management to make sure it works. So first off, you got soil. And this is back in our potato growing days. This was a potato in a well aerated sand with fungi growing around it. That's at about 6 or 7 inches, that potato. And so the fungi is something that we were really surprised came back so quickly in sandy soils. And all we had to do was provide the starter culture there and keep looking after it, and stop putting chemicals on that were antagonistic to that. So for instance, we would halve our rate of Roundup to start with when we were going out and spraying out country, and spike that up with a fulvate. So it's definitely off-label for the Roundup, but And so you won't have agronomists recommend that to you, but you spike it with fulvate actually does a better job, and you immediately bring back to life a lot of those things that you did a lot of damage to. Sorry, you don't harm them quite so much for doing that damage. Then you bring them back to life a bit later on with some biological stimulants like fish and kelp and molasses and humates and so forth. So, and a well-aerated soil suggests that it's air in there that you want. Nothing is really going to happen. Nothing any good happens without oxygen in your soil. So what you need is a space for the oxygen to exist, and that probably starts off with the physical component of the soil. It's actually the physics, not the biology just yet. So if you're fortunate enough to have a good soil, please do nothing to destroy it. Just worship it. Look after it like anything, because it's precious. But if, on the other hand, you are like most of us, and you're going to need a bit of mechanical intervention or something to help after you've got a problem arise, you're going to have to just overcome that. And that may well be mechanics. You can also just use what's already there. They're called weeds. Now that's Capeweed and Erodium, which I know you get your good fair share of on that side of the continent. That was after the fires here that have gone through in January. That was blackened just 5 days before Christmas, I should say. That one that was blackened then, and now it's back with a carpet of Capeweed and Erodium, which are actually doing a job. So you can use them to your advantage, because they're playing a vital role in that soil restoration, and you can get some good biology down through the soil by actually applying something to that Capeweed and Erodium. They got really fast going taproots, and they got really great capillary action, and they're like millions and millions of microscopically powerful drill rigs. So they don't look pretty. They never look pretty. No scab on a soil looks pretty at all. I've said that before. But weeds are Mother Nature's scab on a soil, and Mother Nature hates bare earth. So they're performing a duty that she put them here for, and it's pretty hard to intervene, particularly after such a thing as fire would go through. But even after you might have some weeds in there, they can be doing in your cycle. They can be doing a job for you that saves you some money. They're quite wizardry, and they're quite incredible as to, when you study them, what their decaying leaves will lay down for you. They're pretty short life cycle, and what's there ready for the next plant is just a freebie that the weeds gave you. But too often we actually just want to go out and kill them and get rid of them. What you can also do is get out there and see what tensile strength the soil has got, what pressure the roots would have to work at in order to get down there. So there's two soil pressure testing kits there. One with a gauge on it is quite expensive, and the other one is just a bit of 3/8 rod made into a T that I also use for finding poly pipe around the place. But it's really helpful, and if you just use the tips of your fingers and push that away, that will generally take you up to about the 300 psi. That's indicative of being too much pressure for roots to activate well. Now, the soil needs to be reasonably moist in order to get an accurate reading there. If you do it on dry, hard summer soil, obviously you're going to get a different reaction, but you're not expecting roots to push through a lot of that unless you're going for summer species, which is a different story altogether. So you want to test your soil and know whereabouts any hard pans are, and if you have to do something about them, then now is the time to do it. So that's what we call soil amelioration, and that's a very manual way of doing it. This is a trial that we were running under a centre pivot, and we were putting on varying levels of dolomitic lime, straight lime, some sulphur, and a bit of magnesic sulphur, K-mag out there to see what would happen. So I really enjoyed running my own trials, and I had a good crew around me that would really get involved and see what the outcomes were. And oftentimes we would get some just normal, good old departmental advice. There's nothing wrong with it. It's a little old-fashioned sometimes, which would recommend that we put out 4, 5, 6 tonnes of the hectare of lime. So I didn't want to do that through a fert spreader, and because sometimes you had no idea where it was, whereas this way we could just measure those drums and do it on a small scale and look at our results. So inoculating the soil is really the first step, because you're going to change some of the properties of exchange in the soil. Always think about it. Astronauts, if they were kicked out the back of the shuttle at the space station, they would be immediately weightless. There's nothing to support them there. There's no oxygen or food, no shelter. And it's the same with microbes landing on a really hostile environment and hard soil, and where UV light just knocks them around and starvation gets them as well. And so it's really imperative to have a place to shelter and a place to grow if we're trying to establish the beneficial bugs. You need to know which is which in the gang. And so this is a handy slide for you to come back to, because there's a hierarchy there going upwards from bacteria to fungi to protozoa to nematodes, and what they do in the scheme of things, and the food sources that they like. Their carbon and nitrogen ratio is useful to remember, because that is where you're going to get the nitrogen that you need in the system from, ultimately, by getting high levels of those upper level species of protozoa and nematodes. So balance is the trick with those. You get anaerobes and aerobes, you get endo and exo and shredders and builders and hydrophobic and hydrating, and so start a culture of really good fungally dominant compost and cereals and grass pastures is what you need to apply. You can get cow manure compost, it's fine, but it's bacterially dominant. It's really low, and it needs to be inoculated with a mix of beneficial fungi. And we'll talk about that directly, as what you can inoculate that with. The cow manure compost, well made, is not a bad start either. Plants are fed by microbes, and to a lesser extent their roots. Most people depend on roots for plants to get their nutrition. But if you think about it, a root only occupies so much of the soil. All the bits in between the microscopic areas, what we say all the root hairs gleaning their nutrition from, is actually mostly fungal. It's the hyphae that are searching down in there and bringing the nutrients back to the plant. So what you want to look after. So do whatever you can to add on to the root mass by keeping that fungi going and delivering it back to what I call the right address. You're going to get much better survival. So you can get biology in a bag. Now, this obviously just came out of the nursery shop for more garden type setup, but you can buy those in commercial quantities, and a lot of people do. And you might say, well, I can't afford that. What I would say to you is that they consist largely of live cultures of one kind or another. So you stick to a budget, and we'll talk about budgeting directly, but you can buy those in bulk and various variations on a theme. That biology in a bag is generally going to be good stuff. Now, I've been sold bags of stuff that don't work too, and I've been putting the wrong thing on for the wrong growth. If I was using, if I was growing a root crop, so if you were growing Swedes or turnips or tillage radish or potatoes or carrots or something like that, I would want a really bacterially dominated soil. But if I'm growing grass species and cereals and so forth, I want a more fungally dominant soil. I want really about a 10 or 12 to 1 ratio, and you'll get that if you do a biological test as well as your soil test. We'll talk more about it a bit later on. I'm telling you though, with compost and compost, you've got to know a bit about how it was made in order to get that right. So there's 2 slides there. One's compost made well and compost made cheaply. and the two are generally not the same. So it's very hard to get a good temperature control on a compost pile so big as what those guys are standing on top of, because inside the center of it will be overcooked and probably catching on fire, spontaneously combusting, and the outside is as cold as ice. Somewhere in between, there'll be some okay compost being made, but they generally turn that with an excavator driving along on top of it, which is, again, kind of just going to oxidize a lot of it, turn a lot of CO2 back to the atmosphere. All of the bugs in there are out of whack with each other. The balance is not occurring. Whereas well-made compost will be made in much smaller heaps, up to probably 7 feet high when they're 2 meters, 2.4 meters high when they're turned, and they'll settle down to generally be more like 1.8, 6 foot high when they're settling. And that will give you much better temperature control and a CO2 control. So if you're interested in applying a little compost and starter culture on your country, I would go to where they make it and get a little interested in how they're doing it and ask them those questions about how they manage water and CO2 and temperature in their compost piles, how fast they can make it. Now, if you want to have a well-made compost, you can do it in a short space of time with the amount of with a good amount of input. So you can make good compost in about 28 days, given some good inputs. And you can make really bad compost over a period of a year, just by letting it sit and mulch away. So it's nothing to do with actually the speed that it's made. It's more about how it's made. So you can get biology in a can as well. And there's some off-the-shelf stuff you get out of Bunnings that you can buy in 1,000-litre shuttles, and you can water that down to be just starter cultures. And again, you only put out as much as you can afford. So what that's going to do is immediately you'll get a rise in something. You'll see more earthworms, probably. They'll come back into your focus. You'll get greener leaves, maybe more flowers, less insect attack, sweeter fruit, thicker foliage, depending on whether you are in a crop or in an orchard or in a greenhouse or whatever. But whatever you're doing, you got to remember that these things they're live cultures, particularly the fish. So sea salt is more an amelioratant, but it's got its fair share of living stuff in it. So that will also they'll combine extremely well to be a starter culture for you. And if you've only got $5 a hectare to spend, well, you only just put $5 worth out. So what often happens too is when we apply stuff like this, we put it on and we imagine that something happened, and we look and then maybe it didn't. But we go on and we hope, like anything, that we can actually convince ourselves we've got something to share with our colleagues and mates and go, see, look what I did. I've actually made a change. And if we do, we'll jump up on top of the highest hill and tell whoever wants to listen that we found a silver bullet. And if we don't, well, we say nothing and try to forget that we ever had such ambitions and embarrassed. We kind of go back to what we were doing before and try and ignore everyone who doubted us, but probably rightly so, because we didn't actually know what we were trying to achieve. And we often put this stuff out and immediately kill it again by going back to our old ways. So you have to put out the stuff that is antagonistic first, and then pretty soon after follow it up with something to bring back to life everything that you just damaged or killed. So when you've been sold something that's overstated, you can often not know what you're really trying to apply. And to be sure, we're requiring some live culture biology along with some inert carbon is the first step to the decision making. So we're getting carbon in the form of the inert product in the compost, and we're getting biology in the form of the live product that we add to it and hang on to that compost. So we've got to know if we need bacterial or fungal dominance. We've got to get some soil tests about us to know what we're going to change first up, but we've also got to get hold of some soil biology tests. So there are laboratories all over the country that will do that for you. You just need to make contact with them, tell them what you're trying to grow, tell them what you're trying to do, and send in a soil sample. And you will get a really detailed analysis of something that you probably didn't know much about before. Later on, you can start to get your own microscope if you're interested and do your own inspections. But they're extremely useful tests to have. Most things that come in a bag are pretty well-made compost. That's why they cost a fair bit of money. As I say, most of those bulk compost products are not finished yet. They're sold as finished anyway. You can tell quite easily if you buy compost in bulk and you raise the tipper up and quite a lot of it sticks up in the top of the tipper even though it's fully extended, you can safely say it's not finished cooking yet. The temperature should come down and stay down. If it's still warm, it's not finished cooking. So if it's turned by a giant excavator or by a loader in the making, what they've done is they've just made you good mulch, but they haven't made you, they made good mulch or even biochar, but they haven't made you any decent live culture. So when you get to the average of the center of the pile, on the outside of the pile, as I said, the average is very average. It's not really worth using. It's just fancy mulch. It's not likely to help your soil diversify much at all. And often it could smell a lot like the parent material. So if you're buying it out of the city, it'll smell like the sewage farm where it came from. So to get this stuff out, we got a hold of an old spray rig with a buggered boom on it. That one was used for particularly wet areas, as you can see, and it was one of the early versions of SP spray rigs. The booms were no good, so we just put a boomless jet on the back of that with a good pump and a really good agitator in that tank. You can get a lot of product out very quickly using the wind to your advantage, and I just love those boomless jets. So they allow you to apply it in conditions that's conducive to that stuff living rather than dying in the soil. So you want to maybe choose the end of the day when you're not exposing it to such UV light. You want to use the wind, as I said, to your advantage, and the temperature, the ambient temperature as it's declining is going to help you greatly with it living on. So again, say work to your budget, and you might have to use a little less per hectare if you can only afford that much. But you see, what we did believe in the past, which is not relevant to this, in the past we believed that if lots was good, then more must be better. And see, because you are making a live culture, you're brewing a live culture and putting it out. If you give it the right medium to grow in, it just keeps on growing, a bit like mold on your bread. No one put it there; it just grew as a result of the yeast spores that were originally there. So, lots of you know stuff about keeping livestock alive. So this is all about keeping the microbiological livestock alive, and it's just the same. This is missing to kill earthmite, and it kills biology as well. So a lot of people think that they are doing good things by taking their parasitic insects and mites out of the system by doing that. But it has a lot of negative effects on biology in the soil, because it basically stops what's happening on the skin of the soil. And all of those little nematodes on the surface and protozoa, they are generally adversely affected by those chemicals that were used for insects. Now you could use that same machine to your benefit and take the lemat or fastac out of it and put in a pretty good strength molasses, and it will do just the same. In actual fact, what you'll find is the earthmite will turn around and attack your your sourest plants, or your so what you're doing is making your grasses sweeter than your capeweed, for instance, and the earthmites eat your capeweed. It's quite an interesting phenomenon to see them living under all the capeweed and not on your grasses or your clovers anymore. So that kind of process of misting like that is fairly antagonistic to the environment and not helpful for what we're trying to do. If you look at the humus in the soil, it's got these amazing properties, and humic acid colloids look a fair bit like that under the electron microscope. They have an incredible surface area on them, and surface area to weight ratio. They have an amazing affinity with water, with moisture, and their ability to hold it is somewhere between 5 and 30 times that of clay. So really, I don't think it's possible to have too much humus in your soil. It's just the most wonderful thing. So you can bring it in the back of a truck or try and grow it yourself. And there are ways of growing it better than others. But humus is going to be what's probably saved the planet in the next umpteen years if we get a bit focused on what we really want down there under our feet. It's like blotting paper in the soil. So I say to people that you can't control how much rain you get, but you can certainly control how much you hang on to. And that is directly proportional to the amount of humus that you have in the soil. So if you could imagine an egg carton, next time you got a spare egg carton, just dip it in the sink, weigh it first and weigh it after and see what happens, and then weigh it again a day later and see how much it's holding on to. That cellulitic material in the egg carton is holding on to the water. And that gives you some idea of what a gazillion egg cartons all shredded up just underneath the soil in the form of humus would look like. So the little bit of rain that you get is going to be held onto, and it will have some effect, probably good or really good, on your plants. The ability to adsorb, which is adsorb, moisture, which means that it has an affinity for it, it holds on to it, and then it gives it back to the plant quite easily, is one of the special properties of humus. So it can't be understated how useful it is in our focus. So how to make good humus? Well, firstly, you need the air in the soil, as I said, and if you want to incorporate anything into your soil by laying it on top and then going over the top, I think one of these machines is a really, really useful machine. Now, some people haven't got access to one of these, but they may have prickle chains or something. It's minimal disturbance, but it gets that starter culture somewhere down underneath the surface and allows it to grow and puts a bit of air in there as well. So airway implements are and aerating implements are probably a tool that every regen farmer is going to ultimately have, so they can make sure they're getting air in their soil. And this year it'll go down a certain depth. The following year it goes down a little deeper and a little deeper and a little deeper. And particularly if we create pathways for it with deeper rooted perennials or just deeper rooted plants of any kind, create pathways to go down, well, we're in a winner there. That's where we want it to go. So we can get that blotting paper underground and lay down that humus, because otherwise it's just going to sit on top and volatilize and go back into the atmosphere as CO2, which is where we don't want it. We want to reverse that trend. So the ways to increase the soil health as we're going around the paddock and looking at what we do, the first one is management. So we're going to use grazing management, or we can use cover cropping to start to see our soil health has got to keep progressing. What we often do is for 6 months of the year, we grow something in it where it has a green crop in it, and we progress it, and then for the other 6 months of the year we leave it bare and idle, and it goes back to square one again. So we've got to kind of put a chock in there, and as we're leveraging it up, we've got to keep that chock in there, and the chock is some kind of green material. Now, if you don't want weeds there, then you might as well go out and choose whatever that cover crop is going to be and see how it grows. But management is the foundation to changing the soil health. It doesn't have to come out of a bag or a bucket. It's just about what we do as management. And what we do as management increases the biology. As we go up the pyramid, it increases the activity that's going on underneath there. And so we need to do whatever it takes in management to promote biology. And then in come the catalytic inputs. Now, what I mean by them is things that in small amounts we introduce them to the system and they make a reaction occur. So it's a bit like catalyst being added to resin. You put have a litre of resin, about 1 drop of catalyst goes in there and it causes a reaction that makes the resin go off. Well, if we use the right thing that comes out of a bag, and that could be just a little urea, a little nitrogen as a catalyst, not bulk of it by any means, but just a little, it might just be what we need. And so when we ask our agronomists as to what we should be putting out for a catalytic amount, for amount that causes a reaction, we'll probably get a very different answer from what do we need to feed these plants with. We're trying to get the biology to feed the plants here. And then finally, there's some biodiversity that comes either in the form of, well, we've got Leukina there on the top left-hand side with cattle grazing in there, which gives you a third dimension to what you're doing apart from the grass under their feet. Or we've got some companion planting in our crops. Now, companion planting is nothing new, and I think it's a very underrated practice, and there's nothing to say that you couldn't, in any crop, plant some other larger seed. Well, who says you can't put some sunflower out in a pasture over the summer and just see what happens and take advantage of any summer rains that you might get, because the mycorrhiza that live on sunflower roots particularly, they're a really special fungi that we're all looking for, are going to really be useful to help both species. So there's ways to increase soil health, really, and only one of them cost us a little bit, which was the catalytic input. The rest was just management. However, sometimes we'll have to buy some stuff in. And so calcium is really useful. This is a book that I think everybody should have of Neil Kinsey's called Hands-on Agronomy. It is probably a textbook for everybody in the last 30 years that did agronomy anywhere and any student. It says that at the proper saturation, it improves the soil texture, it makes phosphorus and micronutrients more available, and improves the environment for the micronutrients. So by and large, most people need calcium. Quite often they'll apply lime, and that's good, but lime often stays as lime until it's activated with biology. So you need to put out a carbon source and a biology source when you put out lime to convert that into calcium, because otherwise it just stays around as millions of tiny little rocks as lime and nothing happens, nothing changes. So Gary Zimmer, as a good old trainer as well from the States, and he would say that calcium is the trucker of all minerals. So nothing can be delivered to plants without adequate calcium. So always look at your calcium levels. We often put lime on country to change the pH of the soil. And I wouldn't put anything on to change pH. I would put something on to change the calcium, and the pH will come of its own accord. Don't put something on specifically to change the pH, because first and foremost, it will break you. And secondly, it might not work either. So live carbon source with calcium, and make sure that you don't put it on as a capital application to try and change pH. There's another manual there that was Science and Agriculture. These are probably old books I love having on the shelf and getting out every now and again to refer to. Science and Agriculture is a must for everybody who's going to do a bit of or a lot of regenerative agriculture. Just remember that we've come from a whole generation of saying that if lots is good, then more must be better. It's the moron principle, and it's not ideal, because what we can generally do is choke the whole system up. And it's a bit like saying, there's all the steak that you're going to eat for the next 4 months, but I want you to eat it tonight. You know what's going to happen to your system. So you want to try to divide your lime application up probably into at least 2. Makes it ideal, makes it easier for the system to cope with it at the rate of 20% carbon to 80% lime. 20% carbon source to 80% lime. So when you try to provide the soil environment that has adequate nutrients in it already, and the plants don't seem to be taking up, there's probably a disconnect. And that disconnect is probably the mycorrhizal fungi on a seed, particularly on seedlings. So we would, when we were planting a legume, we would inoculate that legume seed with a rhizome in the bag. So just like doing that, you need to help your soil along with something that's going to kick that mycorrhiza into gear. So just remember, that's a tiny little detail, but it's a really, really necessary one. And I always say that attention to detail is wonderful, but meticulous execution of the task gets a much better result. So the rule 1 is to stay in the game and not go broke. So I said before, choose a budget and stick to it. And a budget is so important. If you lose track of the budget, you're going to lose track of the game. And so stick to your normal fertilizer budget. Use a portion of your normal fertilizer and then supplement that with something that's going to really help you with your biological system. Just remember that most of the nutrient that leaves the paddock is carbon from the atmosphere. We keep listening to a lot of people that tell us we need a lot of stuff, but what you need to do is analyze the grain or the grass or the meat that's leaving the paddock, the hay or the meat that's leaving the paddock, analyze that, and you'll be pleasantly surprised that most of it is going out as carbon. So what we need to put back is just micro amounts, and a lot of that, your biology will extract that from the atmosphere anyway. Arden Andersen would always say, no number is right until all numbers are right. And that slide really just highlights that on your base saturations, you need to get the 68-12-5-2 as the far left-hand column shows in those proportions to get what you are after in base saturation exchange. And be aware of your physical and your biological limitations. So lots of people have seen the nutrient ratios in pH on the left-hand side. Not so many people have seen the soil fibre on the right-hand side, but they both interact strongly with each other and both cause one to be correct. Well, each cause the other to be correct, I should say. So remember those when you go experimenting. I think a mentor to guide you is so important. And I'm not saying it needs to be me or RCS or anybody else, but generally somebody has already made these mistakes, and particularly if they know what the mistakes were and how not to do them again, they're going to be really useful to you. And I think it's important to hand this information down. We can't keep it to ourselves. And there's a lot of young people out there are dying to find out this stuff. This is really popular right now. And I think we got every chance to get a restored number of people back in the industry because God knows we need it. So thanks again for having me. I really appreciate it, Shay. And there was a question I did notice about coccidiostats in chicken manure. So the question was, do they grow, I presume it meant, if they find their way back out into the paddock, do they negatively affect the protozoa in the paddock? And I would say if it were well-made compost that comes out of chicken sheds, not at all, because the composting effect takes care of it. And then what doesn't take, was not fixed by that, then UV light takes care of. But if you just grab straight raw chicken manure out of chicken sheds and go spread that on your country, you might be asking for a bit of trouble.
Thanks, Nick. I think there was a lot of really good take-home messages in there. I loved the analogy with the egg carton and the carbon and how much water holding capacity it has. I think it's really visual for people to be able to think about that when they're thinking about putting carbon back into the soil and how about they do that. And the fact that you mentioned like the time of the day when you apply things to the paddock, so you're trying to avoid the peak, like the heat of the day, because that's obviously making it a bit more of a hostile environment, hey?
Yeah. Yeah, for sure. It goes, it's pretty intuitive, you know. If you're thinking these are microscopic organisms you're trying to keep alive, you've got to look after them.
Yeah, of course. And then like when you're talking about the earthmites, so that would be like red-legged earthmites. If you, instead of putting out a spray on them, in some instances you could make up like a molasses mixture, and then they would target the weeds, or like your capeweed.
Yeah, I'd use them to my advantage. So they're gonna be tough to kill anyway. So we might as well turn them on our weeds and use them to exterminate weeds for us. And I've done it time and again, and it amazed me the first time I did it. And all I used was a change in management, obviously, and my catalyst was molasses, 2 litres per hectare, 3 times, 2 weeks apart. There's a recipe.
Yeah, no, I think that's great. I hope that there's lots of things that you've mentioned today that lots of people can take home, as they can go straight out in the paddock, and whether that's welding that T-piece together in the shed and then heading out to the paddock when the paddocks are a bit more moist, and measuring the pressures and seeing what those root systems really have to deal with. I know that your computer battery is running a bit low, so I don't want to have you cut out on us. So if anyone had any last minute questions, but otherwise I would like to say thanks again for joining us, unless there was any other real key messages you want people to take home.
No, other than just get into it and do it, and just have fun doing it. It adds so much fun to agriculture doing this. It really is great.
Yeah, I think of like when you were talking about doing your own trials and stuff like that, I think that's a really good way of doing it. And like you've mentioned previously, and you just start off, even if it's a paddock out behind the shed or something that's not, people aren't familiar with or don't often see, and then you can just start there and practice and see what happens.
Absolutely.
Yeah. Thanks, Nick. Thanks again for joining us, and I really appreciate you giving us your time today and for the last 2 webinars that you've done. What we'll do with this one is, like the other ones, make them available online via our website, which people can then use as a resource and go back to. So yeah, thanks again, everyone, and thank you, Nick, for spending.
Thank you. Thanks, Shay. See ya.
See ya.